Now what you're looking at is a 20-year-old Norco downhill bike. I initially got this on Facebook Marketplace for only $100, and it was pretty much headed for the junkyard when I found it. But thanks to the power of the TSDZ8 from flycaddycat.com, we were basically able to transform this old bike into a pretty capable e-mountain bike that rivals the performance of bikes that cost at least 4 times the price. Now we did overhaul the bike almost top to bottom to make it road and off-road worthy. We're also going to talk about the mid-drive system, the advantages that it has over a hub drive system, as well as talk about the entire build process, the cost breakdown, and whether it's even worth building your own e-bike or e-mountain bike compared to just getting one from Amazon or anywhere else just off the shelf. So let's get into it. Now the world of e-scooters and e-bikes have pretty much exploded in the last couple of years. They're pretty much on every corner. If you had to pick one, I certainly think that the e-bike is certainly the more capable piece of transportation. You can go longer distances since you can power it with your human legs, and it gives you some exercise, which is always nice, opposed to just standing on an e-scooter and doing nothing. Now, for the longest time, I actually had a couple of e-bikes in the past. I've had a GoTrax EB3, and they're great for the price and great for general transportation, but they do have some long-term durability issues, and serviceability is always a concern as well, since many of these companies are kind of startups and they go out of business and you might not have the parts availability for long-term future use. So for example, I had a GoTrax EB3 that was about 3 years old. It had about 2,000 kilometers on it and had several broken spokes thanks to the hub motor, which was just too much torque for the wheels themselves. And typically with these cheaper wheels and these cheaper e-bikes is they don't have the most highest quality components, and off-road capabilities are always really sketchy. They're pretty uncomfortable when you go off-road and you barely have any power to get up most hills. On top of that, you also had a laundry list of maintenance issues, not to mention the mechanical disc brakes were fairly inadequate. So for the longest time, I did want to pretty much make my own e-bike with a good solid frame that you can go off-roading, on-roading, and be good for commuting, as well as just having just general fun. And the world of converting regular old bikes that you find on Facebook Marketplace has been around for many years. Typically, people get hub motors, replace the rear wheel, zap strap, an old controller, and a throttle, and there you go. But it's only been very recent where the proliferation of mid-drive systems have become really popular. Mid-drives are pretty cool in the fact that they have a controller built inside the motor unit assembly, so they install very cleanly, and you only really need a battery to really convert any push bike into an e-bike system. Mid-drives install into the bottom bracket or where your crankset is installed, which is pretty much universal on any bike, and you can easily swap out the mid-drive from one bike to the next relatively quickly and easily. The big benefit of a mid-drive is that it utilizes the existing gears on your bike. So on your rear cassette, if you have a 10-speed, 12-speed, or whatever, you can actually utilize those gears to get you better ratios to go up steeper slopes, as well as increase your top speed and overall performance. Mid-drives are also more efficient than hub motors since they can utilize torque sensing for your pedal assist a lot more efficiently, and that's one of the big benefits of the Tongsheng mid-drive systems. They have torque sensing versus cadence sensing, and they typically give you a more natural pedal assistance, as well as be very efficient in terms of battery life, so you can get more range as well as better efficiency out of your battery. The only real downside to a mid-drive compared to a hub motor is that if you do break your chain, which can happen sometimes because most of these mid-drive systems have at least 80 Newton meters of torque, which can definitely break your chain or damage your drivetrain, but there are some ways to prevent that from happening. But if that is the case, you are going to need to repair your chain to go on forward, versus if you have a hub drive system and you break your chain, you still have the hub, which is a separate drive system from your main drivetrain connected to your crankset, so you could easily limp yourself home if need be. Now, thanks to flycaddycat.com, which is one of the best resources for mid-drives, I was actually researching how to get a mid-drive system, and I found that their pricing were some of the most aggressive online, even better than AliExpress. And the shipping is pretty fast, as well as very affordable. And they have 3 warehouses in China, as well as in Germany and the US. And they also have Tongsheng, as well as Bafang amongst other mid-drive systems. So I would definitely recommend them as a great resource if you're interested in starting your own mid-drive e-bike project. Now we're going to be specifically installing the Tongsheng TSDZ8. This is one of the latest generation of Tongsheng mid-drive systems. I've actually used the original TSDZ2, not the non-B version. And I really like the torque sensing system in there. It didn't have a throttle, so it was only just pedal assist only, but it was a relatively affordable and very capable torque sensing mid-drive system. But the TSDZ8 is certainly a lot more compact, lighter, and more powerful than the original, as well as I think offers some key benefits, especially with that torque sensing compared to other competitors. I also have the Bafang BBS02B, which is the 500-watt mid-drive system from Bafang, one of the most popular mid-drive options on the market. And although it is very powerful and very peppy in terms of its torque response, the cadence-based pedal assist system doesn't feel as natural as the torque-based pedal assist system found on the Tongsheng mid-drive systems. And I did find that they're a little bit more bulkier and heavier than the TSDZ8. Now, as far as the bike goes, I purchased a Norco VPS from 2005 on Facebook Marketplace for about $100. The initial bike was pretty much in super rough shape, pretty much scrap metal for the most part, but it did have a very strong frame, and I know Norco is an awesome bike company that's actually local here in BC, Canada, and I knew that it would be an awesome e-bike conversion because of its heavy-duty construction. The geometry of the frame is a little bit dated, shorter, but actually very, very comfortable, very similar to most e-mountain bikes actually, or specifically e-motos in terms of how it feels when you're sitting on the bike itself with the shorter handlebars, and would be a great option for both on and off-road circumstances. Now, as far as some of the usable parts on the bike initially, the front hub was actually pretty good. It spun very fluidly. It certainly can be replaced, but the front hubs typically last a very long time. The Marzocchi front suspension actually feels pretty good. It's probably never been rebuilt, but it doesn't leak, and it actually absorbs bumps pretty decently actually, and super comfortable. The rear Fox suspension is also fairly serviceable as well. I can obviously replace the spring and the dampener, but as is, it actually worked pretty good for my needs, and with a little bit of WD-40, it stopped creaking. Now, as far as the things I definitely needed, it was definitely a new rear wheel with a new hub, because the bearings on the old one were completely shot, as well as new front brakes, because the Haynes 9s hydraulic disc brakes at the front were pretty much leaking as well. So I replaced them with a more modern Tecro hydraulic brake set, which is found on most kind of budget-friendly mountain bikes and e-mountain bikes, and they're fairly good and affordable hydraulic brakes. The original Shimano rear brakes are actually fairly good. They work great. I just needed some new pads. Now, we're not going to need the front derailleur or the crank set of the original bike, so that's pretty much a garbage. And really, to install any mid-drive system on any bike, the biggest challenge is getting the bottom bracket off. So typically a bottom bracket has a, obviously your crankset pedals, and you want to make sure that you have a crank puller for that. It's a pretty affordable tool on Amazon. And you also are going to need to know whether your bike is an Italian or British standard bottom bracket. Typically with a British standard bottom bracket, which is the more common one for most relatively newer mountain bikes, you have the drive side, which is a reverse thread, so it actually loosens clockwise and tightens anti-clockwise, and the non-drive side is the opposite of that. And you're also going to need a special tool for removing the end cap fittings of the bottom bracket cartridge itself. You're going to have to refer to what bike you have. And Parks 2 has actually a great tutorial on how to remove bottom bracket from most common bikes. So we'll definitely link that video in the description down below. For my specific Norco, it actually used a weird fitting for the end cap, and I pretty much had to kind of grind out a little notch and hammer it out in order to get it out. It was pretty much garbage to begin with, but if you're using a more relatively modern bottom bracket that has some sort of notch-based end cap, like a 20 or 16 notch, you can buy that specific tool. Like on my Brody bike, it was really easy to actually get the proper tool and remove the bottom bracket unharmed. Now, once you have the cartridge out of the bottom bracket, you want to make sure that your hole is about 33.5 millimeters in terms of its opening. And on my Norco, the clearance was no problem. The mid-drive went straight in without any issues, and I didn't even need any spacers to get the alignment correct. Now, you might need some spacers on either end to make sure the actual front chain ring doesn't actually hit anything on your bike, but in most of my cases, I didn't really need any spacers. I did find on my Brody bike, which is a little bit more modern, I had to Dremel out about 1 millimeter or 2 right in the center point of the bottom bracket to make it fit through. It went through the threads, but the unthreaded part, it kind of got stuck. So you might need to do that if necessary, but in some cases, the mid-drive should just go straight through. Now, the length of your bottom bracket for most mid-drive systems is rated from 68 to 73 millimeters in terms of length. If you have a fat bike or something that has a longer drive shaft, there are some adapters that you can extend the drive shaft of your mid-drive to make it fit your accommodating bike. But most mid-drive systems will ship with compatibility of bottom brackets that are 68 to 73 millimeters long. Now, once you have your mid-drive system slotted through the bottom bracket, it's just a matter of putting on the outer bracket, screwing it in with the proper spacers, and then taking the main lock ring screw and tightening it into place. With the Tongsheng TSDZ8 as well as the Z2 that I had, it actually came with a specialized wrench to tighten it down, and you pretty much tighten it down to where it feels pretty much secure and you can't tighten it anymore. Unfortunately, we can't torque it properly, but I've installed most of these mid-drive systems more than a dozen times, and I didn't find it slipping or coming loose over time. There's also an outer lock ring to give it a little bit more security, as well as make sure that main lock ring is in place, and it makes the mid-drive look a little bit more sleeker with its black cover. Now, as far as the battery mounting goes, you can typically mount a battery on the down tube, whether that's on top of the down tube on like a hardtail or underneath the down tube like most full suspension mountain bikes. Now, if you're using the bottle mount screws of a hardtail, you can kind of use those if you want to mount your battery mounting plate to that. But the problem is they were made for a water bottle, not a very heavy and kind of dangerous battery. So I always recommend threading in your own inserts using a rivet tool. So you want to drill some holes and add some more mounting points. And since we're going to be mounting it on the underside of the down tube on our Norco, we can add at least 3 M6 style threaded inserts. Now, the process of installing the inserts is pretty easy. You pretty much mark your mounting points of where you want your holes to go. You drill a hole and then you use the rivet threaded insert gun to install the, in our case, the M6 threaded inserts. We then use some spacers, some M6 bolts to bolt down the battery backplate. And we're using a Heilong style e-bike battery. It's 48 volts, 13 amp hours. And I've had this battery for a number of years now, and it's decently safe based on our experience. But if you are buying a new battery, there's always a risk factor of fire, especially charging or transporting. And you always want to make sure that you're charging it in a safe area, preferably outside, away from any fire hazards. But once you know a battery is relatively safe, you can be a little bit more free with it. But generally speaking, the battery is certainly the most dangerous and most critical part of any e-bike build, and you want to be careful when dealing with it. Now, I got this battery off of AliExpress for under $300 and had no issues with it. And the performance on it is actually relatively good with excellent overall battery life and charge times. The battery also comes with a key, which you can lock the battery into the back plate, which is always a nice security feature. Plus, it's always nice to have a removable battery if you want to transport the battery with you if you're out commuting. Now, once the battery is mounted, we can now do the wiring, which is pretty simple and straightforward. You want to obviously connect the battery to the mid-drive. So I crimped on some bullet connectors for the positive and negative terminals and did some cable management. Next, you want to install the speed controller And this pretty much is a magnet that goes on your spokes and then connects to the speed controller sensor unit itself. You simply zap strap it, and this is pretty much an arrow where it should see the magnet. You want to have about 3 to 5 millimeters in terms of clearance from the magnet to the speed sensor, and you obviously don't want to have it too close. But once you have that speed sensor installed, you simply connect it onto the mid-drive system. We also tested out the mid-drive system to make sure everything was working. So I connected the display as well as the throttle and tested it kind of off the bike to make sure everything was working. Once everything was working properly, I then moved on to the cockpit, slid the throttle on the left-hand side since that has no front derailleur anymore. There's more room on that side. And we mounted the display on the center stem piece. Now this kit also came with some brake levers for mechanical disc brakes. Now since we have a hydraulic disc brakes, we're going to actually use our own sensor that uses a magnet for proximity sensing. And this basically acts as a brake cutoff switch. So when you're braking, it's not going to apply any power to the mid-drive system. You can also use it as a clutch when actually shifting. So when you're shifting, there's no power being applied to the drivetrain to prolong the life and overall wear and tear of your chain, as well as your rear cassette. Now on top of that, I have installed some 3D printed parts, including front and rear mud guards. You can find these on many online resources to print on your 3D printer, and it works universally on pretty much any mountain bike with some zap straps. On top of that, I also want to make pretty much a throttle position lock, since sometimes I'm commuting on a long stretch of road and it's nice to have basically some sort of cruise control, and without doing a firmware custom upgrade where you have cruise control. Most of these mid-drive systems don't have that option. So I designed basically a lever system that would use friction with a zap strap to hold the throttle position into place. And you can pretty much engage the throttle lock and it'll stay in place. And if you want to disengage it, you simply flip up the thumb throttle and it'll go back into place. A pretty simple and straightforward design. And if you want a similar solution, I can throw this up on Thingiverse or something like that if you guys are interested, because this can be used on pretty much any thumb throttle, whether it's on a scooter or mountain bike. And it's a great way to have cruise control in a simple and easy to use fashion that's universal. You just want to make sure that you have the right diameter for your hand grips and make sure you have the right thumb throttle in terms of its clearance on the lock mechanism. Now lastly, you can add a portable light. I have a battery powered one that I can mount onto the handlebars or anywhere on the bike if needed, which is a simple and easy solution. But you can also hardwire a front light as well as a tail light to either the battery itself or to the speed sensor Y split point. Now, as far as the price breakdown, we paid about $100 for the bike on Facebook Marketplace, $70 for a rear hub assembly, including a Maxxis tire on Facebook Marketplace. We also found a front hydraulic disc brake from Tecro for only $15 on Facebook, as well as $20 for a brand new chain from Amazon. The mid-drive system is around $475 Canadian shipped from flycattycat.com, and the battery was about $270 shipped from AliExpress. Now, all in all, that's just around the $950 marks. We did also spend about $150 on tools and supplies to make this build possible, but generally speaking, the bike itself was under $1,000. Now, overall, the build looks extremely clean. I love the all black look. It looks like a little e-moto, and it integrates really well with the old Norco design. It still looks very modern to this date, in my opinion. And now with this mid-drive system, it looks even more meaner and definitely beefier as well. And the overall performance and riding capabilities of this thing is quite awesome. It's super capable off-road with the front and rear suspension. You can go on any bumps or curbs without feeling really anything, and it's great on all surfaces, gravel, rough road surfaces, or bumpy, rocky conditions, and it really handles everything great, even with the original forks and rear suspension. The TSDZ8, in terms of its torque performance with the 80 Newton meters, is more than adequate for most riders out there. Plenty to go up pretty much any incline you can think of, especially with the gear ratios that we have over here, which is a 10-speed gear ratio. Certainly you can change the cassette to make it more comfortable for going really steep inclines if necessary. And the torque sensing capabilities is, I think, the best in the business. Really feels super natural, and it's very efficient in terms of battery life. Yes, you do need to use a little bit more muscle power than the Bafang system, but you are gonna result in better overall battery life and range as a result of the torque sensing system. The throttle is also fairly responsive and quite torquey. You want to make sure that you have the right gear when you're first starting out from a zero position. But once you get going, it's actually very, very capable. There is a speed limit sensor to 25 kilometers an hour if you want to be safe in terms of meeting the e-bike regulations in most regions. But you can turn that off, and off-road circumstances, you can go up to 45, even 50 kilometers an hour with a little bit of pedaling and the right gear ratio. Another big benefit of the Tongsheng system is that the drive itself is super quiet and refined. You basically don't even hear it. You can certainly feel the power, but it feels a lot more refined than the Bafang system, which definitely has a higher pitch whine. And I really like the fact that it's almost silent in terms of its operation. Now, I've actually put on a couple of 100 kilometers on this bike already, and honestly, my experience has been almost flawless. A little bit of tuning here with the shifting here and there, but as far as the mid-drive goes, its overall reliability and range and everything like that is excellent. I can get to at least 100 kilometers with pedal assist, and there's certainly a lot of power in all of the assist levels. Not to mention, it's kind of nice to have that throttle just in the circumstance that you need to get away, especially when you're commuting within a given situation. And it's nice to have, especially when you're initially going. It's kind of hard to pedal a bike that weighs almost 80 pounds. So to have that throttle and the torque supplied by the mid-drive is definitely a nice thing. Now, ultimately, it was actually worth doing this project to take an old junkyard grade mountain bike and convert it into an e-bike. I definitely think so. Even given all the time and effort and kind of hurdles figuring things out, I still think that the fact that we took an old bike that was headed for the junkyard and made it so much useful and such a viable piece of personal transportation is definitely a worthwhile endeavor. Not only is it super sustainable, there's so many Facebook Marketplace bikes that you can get, and I think a mid-drive system is definitely the way to go. You utilize the existing drivetrain, the wheels, and it kind of keeps the essence of biking and push biking in general, especially with the torque sensing. You could just go further, especially if you are a little bit older and not that capable of biking. The mid-drive system is definitely the way to go, and really, really awesome, especially for off-road purposes, not to mention just commuting as well. On top of all that, we can take out this mid-drive system and easily install it onto another bike if needed in the future. And certainly from a price perspective, there's a huge benefit since we're less than a quarter of the price of any good new e-mountain bike. With the capabilities of the thing, as far as commuting goes, it's certainly more capable than your average commuter or e-mountain bike. And it's fully modular and very upgradable. We can upgrade the battery to get more power range in the future, or change any of the parts relatively easily since we built the thing in the first place. But really, on that, guys, that's really it. Definitely want to thank flycattycat.com for giving us the opportunity to test out the TSDZ8. Without them, this video certainly wouldn't be possible, and I would definitely recommend them if you are looking for the best deal and pretty decent support for any e-bike converting solution. It's an awesome online resource. And if you want to see more videos like this, we would love to do more projects. I actually have a Brody hardtail that I'm working on converting right now, so definitely let me know if you want to know how that goes. But other than that, guys, I want to thank you guys so much for watching. Please make sure to like and subscribe if you haven't done so already, and subscribe to the channel. We'll see you real soon in the next one. Take care.